It's Don here from the board. Thanks for coming along and checking out this video. So today I'm going to try to explain how to test your PCB in some very basic terms so that you can figure out where to wire jump when you lift a pad. Now this is actually a really challenging I suppose tutorial and a bit of theory for me to teach because I'm very rambling, and as you would already know that, and this is already my third attempt, so please bear with me if I do get a bit sidetracked. However, before we get on to that, I'd like to say that this video is sponsored by PCBWay. So PCBWay is a full service PCB company, and they provide services for PCB design as well as PCB assembly. Now you can see that there we go. They have currently a assembly service promotion, $30 for 1 to 20 pieces. They are a one-stop solution for everything that you are after, and with a 99.6 satisfaction rate, that's pretty good. At the moment, if you are brand new and you've never used PCBWay before, they've also got a $5 bonus for new members for 10 pieces, 1 to 2 layers, as you can see there. So, please go check them out if you're after some PCBs for prototyping, or possibly give them a go if you want to be running a group buy and getting some PCBs into production. Thank you, PCBWay, for sponsoring this video. Right, so what I've got down here on the tabletop is I've got a whiteboard, I've got a multimeter, and I've actually got one of my PCBs that I've previously designed. This is one of my more simpler PCBs that actually has a matrix, and that's really important because you kind of need that to understand what I'm talking about, and hopefully I'll use this as an example to show you what I'm talking about. But before we get to that, let's just have a look at a really basic PCB matrix and the components for a keyboard matrix. So if we take the example of let's say a 3 by 3, hopefully I'll have enough space. We're going to go with, there's a switch, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So that's your PCBs. And then typically you're going to have a diode with each one of those. Okay. That. Right. And then somewhere off, you're going to have a MCU, right? And that's either the actual processor itself, or it might be something like the Pro Micro, an Elite C, it could be a Proton C, could be anything, whatever it is that is actually driving your keyboard, and you'd be flashing your QMK and everything else on top of that. Now, this kind of stopped me up in the previous attempts because I was running stuff series and in parallel, but hopefully this will work a little bit better. Okay, so you're going to normally get one of these pins going to your diode, and then the diodes will go to a common rail. And it will look kind of like that, right? And that would be row 0, row 1, row 2. Just got some things stuck there. Okay. And then of course you're going to have columns, right? So you're going to have a column that will be running like this, and that'll be column 0, column 1, column 2. And this is generally the good practice way of doing things. And the reason why I say generally the good practice way is this allows your matrix to work if you do lift or break one pad or one section of a trace between the common to the switch. Now, what I had done, and I'd made a mistake when I drew it in a previous time, was that I had written them in a series way where I'd gone column to column to column. Now, you can still do that. You can still design your matrix and you can still run your traces like that. But the moment that you lift one of these column pads, the entire column below it can fail because it can no longer electrically pass to the rest of that column. Whereas when you've got a common row like this, it doesn't matter if this one fails, these will still travel through that common column. So it's very important to think about that when you actually design your PCBs, that running stuff in series, you do have an inherent risk that if you do lift a pad or you damage a trace somewhere in between, that you're going to actually cause more problems. Okay, so this is what a standard sort of 3x3 would kind of look like. And from the MCU itself, you would have, obviously the connections, C0, C1, C2, and then you'd have coming off it as well, your R0, R1, R2. And what happens is when a key press is conducted, let's say over here, the bridging occurs, a signal path would be created between C1, travels in through here, goes in through the diode, comes out through R1, and the MCU would detect a C1 out, R1 in, or it depends on how you want to look at the electrical pathway, positive, negative, doesn't matter. These two pins trigger, and in QMK it says, oh, a C1 R1 equals this value, output that value. Okay, and that's what essentially happens. Now, what happens if we lift a pad? Well, there's two possible pads on each switch that you can lift. So let's take the first scenario, which is where you lift the column pad. Well, how do you know that you've lifted a column pad? How do you know if you've lifted a diode pad? A row pad, sorry. You need to test. And the testing will tell you if it's going to be a column or a row, or if it's going to be a column or a diode pathway. And here's a multimeter, and what you want to do is you want to set it to one of the ohm settings, okay, with that ohm symbol for continuity testing. Now this is a really cheap multimeter. It's only $10, and it does the job beautifully just fine. Two probes touch together, and you'll see it starts to show a value. This one gets down to about 5 ohms on a good day. Yeah, sorry, 0.5 of an ohm resistance. So it tells me I have electrical connection. Now, if I lift a pad, let's say I strike out that pad there in the middle, right? I don't know if you're going to lift a pad in exactly the middle of your matrix, but you will always have switches around the one that you've lifted. Even if it's in the top corner, there's going to be switches around it, right? Even if it's the bottom corner, you're always going to have switches around it that will help you diagnose what's going on. So this is where things start to get interesting. Okay. Before you can figure out what's going on, you have to understand how the designers have built their matrix. And by doing that, you test the matrix on switches that do not have the lifted pad. So you've got a whole bunch of them around the outside that you can test and you can check. So using your multimeter and your continuity testing, you want to see if you have a column or if you have a row. Obviously, I can't test the switch that's busted, so let's just go to the one above it, right? If I put it on a identical one that's busted, and I go to the one below it, and I get a value, I know that there must be a connection, a trace between these two, up and down, right? So there's a very good chance that I have a column running this orientation. If I touch between this one and this one going this way, I generally won't get continuity because these two pathways are not connected. Now, the only time that this will actually happen and is true is if you have a duplexed matrix. And that's okay, because that is effectively the same as if we've gone and touched there, right? There is an electrical connection. So I can test over here. I won't get a reading in this particular matrix because these are two different columns. I test over here, I test over here, I test over here. I can identify I've got a discrete column of connections this way. I can test over here, and I have connections over here. So I know with relatively good confidence that this is a column that's been lifted. And in theory, I should be able to now bridge from this to here, or from this to here, and my matrix will be restored. Because if I go and draw that in, I need a different color. Okay, let's go with purple. Because if I now do this, the electrical pathway will still come in through column 1, in through here, into that pad, through there, but because there's no connection here, but then I close this switch here, like we did before, it will still come in through C1 and exit and out R1, and therefore give me the same signal. Hopefully that makes sense. Okay? So that's the circumstance in identifying if it's a column. Now, if our circumstances are slightly different to that, okay, let's restore the drawing. There we go. And now, what we've got is a lifted pad over here. Okay, so back with our multimeter, doing our theoretical testing. Okay, if I go from here to here, I've got nothing. There should be no signal, right? Because they're not interconnected. There's no continuity here, right? If I go from here to here, it's still not going to work because the diode prevents electrical back current. But instead, what we can do is we can test the column. If you do this and you have continuity, you know that that's the column, which means that has to be the row. But we can confirm that by checking around. So we can go from here to the back of the diode. Yes, we have continuity. From here to here, we have continuity, right? We can go here to here, we have continuity. Here to here, here to here, we have continuity. So by lifting that pad, all we need to do is re-establish this bit in the middle to the back of the diode. And that should fix it. It's a very simple test. It might sound complicated. I hope it doesn't. And hopefully my little drawing here doesn't make it look too complicated. But once you actually get your probes out and you actually start touching in between points, you will see what I mean. Okay? Now you want to do this testing without the keyboard being plugged in because you don't want to cause shorts and other issues. Now, I've got a PCB here, right? One of my own creations, and it's quite common in the amateur space that we will run diodes we'll run columns on one side and rows on the other. It's like a good practice, and it helps with your routing. So on this side, now that's slightly out of focus, but you'll see that I have all of my verticals running down my major columns, and then on this side I've got my rows running horizontally, primarily here. Okay, there's some funny bits of tracing that I've had to do to get some to get some correct routes going, but for most part it follows that convention of rows in one direction on one side and then columns in another direction on the other side. So on this column side, and I'll show you this, is, you know, there's my continuity. So if I go from this column pad to this column pad, I'm getting a value, 1.8, 1.7. So there's a 1.2 resistance there. And then if I go up to this one, I get a reading. This one, I get a reading. So I know that these must be interconnected as a column. If I try this one here, which is the next one over, and I go up here, no value, right? If I go to here, no value. If I go to here, there's no value. If I go sideways, I'm not getting any particular values. Now I realize that there's no diode connected, but it wouldn't matter because the diode prevents electrical back current anyway. Now, if we flip to this side, which is my row side, okay, I can test against the actual pads of the diode. And this is a little bit harder to do because I'm obviously a bit further away. So if I touch it to one of these pads and I go to the side of the diode, you can see the value now drops again on my multimeter. If I go to this side, nothing happens because obviously there's no diode there. But I can essentially confirm, if there was a working pad here for a switch, that is a diode connection. So I can extrapolate that and test the one over it. Yep, it's exactly the same. I can test the one over that. Yep, it's exactly the same. So it gives me relative confidence that if I've got a pad in that position and there's a diode nearby that matches the same switch position, then it should be those two components. And then I can solder my wire jump from there to there, and I should be able to reestablish that connection. Okay. So I hope all of that made sense. I realize that it might be a bit confusing if you haven't had a lot of opportunity to play around with keyboard matrices, PCBs, and testing with a multimeter, but it really is quite simple. Okay. So just to recap, if you test one of the two in a particular direction and you find that they're all interconnected, then that's likely to be your column. And then if you test the pads around and they're not interconnected, then that's most likely going to be your row or your diodes. So you only have to go from the pad to the base of the diode as long as it matches up with the ones around it. Now, just to wrap up on that, there are obviously going to be exceptions, and there's always going to be exceptions, because if you're talking about duplexing, it gets a little bit more complicated, and if you talk about multiplexing, it gets even more complicated yet again, because in duplexing, your columns bend around, so you actually can end up with your columns doing this, or even columns doing this, and that's complicated. But if you understand that there's a chance that it can happen, you can still test around it and map it out. You just open up or get a piece of paper, mark your switches, test, yes, 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 no, 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 yes, 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 no, 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 and you can go, okay, these are how it's all connected. In multiplexing, it gets a little bit more complicated because you actually run diodes in both directions. So what happens is you end up with a diode, and a separate row where your diodes go in the opposite direction. That's a little bit more complicated, and I'm not really going to go into that, but that scenario, you can still do it. You just have to think about it a little bit harder and logically on which side are you testing. Are you going to be testing from your pad to this side or your pad to this side? And that's kind of easy to understand because on diodes, if it's an SMD diode, there's always a line mark. It can be colored or it can be etched into it. Whereas if you're on like a through hole component, like one of those glass ones, you'll typically get like, you know, the orange body bit, and then you'll have a black line. Sometimes it looks like a brown line, and that is the same as the etch mark. And this one will be in that orientation, whereas this one will be in that orientation. So as long as you understand your diode directions, you can always test against the correct side of the diode to find your rows. Now, I'm going to finish off just with the 3-case scenario on what's broken and what are you trying to jump. So here's your 2 switch holes, and then we're going to have the diode. Okay, that goes off to your row. There's your row, and then you've got that. Shouldn't have drawn that in green. Let's take care of that, and let's, I don't know, draw that in purple. Right. So in your matrix, if your switch isn't working and you suspect it's the switch, you've either got a broken connection to your column, right? So your column is broke. 2, your pad to diode is broke. And that's what I was talking about testing, right? Going from the pad to the back of the diode and checking that. And in more extreme cases, and this I've never really encountered before, is 3, which is where your diode to MCU or the row is broke. Now it depends on if they chain it in series or if they chain it in parallel. So if you have a look at the one that I've done, mine's actually in parallel because, for example, these go to this common row. Now, let's see if I can play with my camera settings right now and help get that into focus so we can see it a little bit better. Camera control, focus, apply. Okay, there we go. All right. So if I lift this, will it give me focus? Oh, it tried it. It's not doing a fantastic job. Okay, maybe it's because of the glare. All right. So on this bottom row, I've got D9, D10, D11, and you'll see very poorly this right-hand side through hole actually has a little line that goes across, and this one just goes straight into it, and this one goes and does this right hand. Maybe this will help a little bit better. Try and not get the glare. Okay, yeah, there we go. So on D9 you'll see it goes on this right hand pad here. It does this little hook to the left, and there's a common row, and it runs, and this D10 does this left hand hook, and the D11 does a right hand hook, and they connect to a common row. That's the common row that I'm talking about. This means that if this pad fails, it will not prevent D9 and D11. Well, it won't prevent D9 from working because it can still connect to that row. If these ran in series, so D9 went to D10 and D10 went to 11 and D11 went to the MCU, if D10 failed completely, then 9 would get stuck at the D10 and there's no common rail, right? And similarly, this one's a badly made one. This is one of my earlier ones, but you'll see the column goes from that column to that column, and this is the series that I'm talking about, not the parallel. So if I had broken this one in the middle, this pad here, then this switch is also going to fail because it has no path to get into the rest of the column towards the controller. So I think that's probably enough. We're talking 25 minutes. I'm repeating myself there a little bit, but wow, February 2018, 2 years. 2 years of messing around with PCBs. But they're the 3 scenarios that you're potentially going to be looking at, and hopefully that'll give you an idea. Hopefully I haven't confused you too much about how to test with a multimeter. If you have any questions, of course, please ask in the comments below. Hit us up on email, theboardpodcast@gmail.com if you like. And yeah, we'll see if we can do our best to try and help you out. Right. I hope nobody's brain exploded. I know that there's some really great people out there who are far better at explaining this kind of stuff, but I thought I'd have a crack at it because, you know, I have been helping out people recently trying to identify their matrix and drawing lines on pictures and saying test here, test here. You know, if you get a value, then you get this, and you should be able to jump from this point to this point and stuff like that. Woo! All right. Long, complicated, convoluted. Hope you enjoy. And yeah. Thanks for watching the video. Hit that like button, of course, if you like this kind of stuff and you want to see more or even a redo or a better version of this. Please hit share if you got any friends who have lifted pads and they've got a multimeter that they can try to do some testing with to do some wire jumping. And of course, I think at the moment, like 90-something% of all my views are for people who are not unsubscribed, who are not subscribed to this channel. So if you do want to get updates and whatnot on latest videos, creations, designs, wacky stuff about keyboards, reviews and things like that, please hit that subscribe button and that bell notification to get notified whenever my new stuff comes out. Rightio, stay safe, be healthy all, look after each other, and of course, as usual, until next time, happy clacking.